In this video, I am going to introduce the idea of the apportionment types of problems. Apportionment are also a variation on fair division problems, but they have a slightly different twist. So an apportionment problem is a fair division problem where players are entitled to differing percentages of a set of goods, but must receive a whole number of items. This is slightly different from the fair division games we've played before, where each player is entitled to the same amount. In an apportionment, each player is not entitled to the same amount, but they're actually fine with it. The tricky bit of apportionment is that this is a discrete fair division problem, so we cannot subdivide the items. Another thing that's important is that all of the items are identical and indivisible, so we don't have to worry about how people value each item. Now, there is a lot of applications of apportionment, but the traditional problem that everybody starts with is in this situation. In 1787, when the United States Constitution was being drafted, one section of it read, "The representatives and direct taxes shall be apportioned among the several states which may be included within this Union according to their respective numbers." In other words, this is a section of the United States Constitution where we outline the creation of the House of Representatives. Now, the United States has 50 states, and there are 435 seats in the House of Representatives. This is a little bit too big for us to handle right now in an introductory course, so we're going to make a smaller example that's easier to deal with. The only thing that really changes from the real example to my smaller one is just the number of calculations that we have to do. The ideas are going to be exactly the same. So an important vocabulary word here is the standard quota, which is unsurprisingly abbreviated SQ. The standard quota is simply the number of seats that a state will receive in the apportionment. So here's my example. I have a country that I made up named Catan. By the way, if you get the reference, you're awesome. Anyway, my made-up country consists of 5 different states, and because I am boring, I'm just going to call them State A, State B, State C, State D, and State E. They have a total population of 100,000 people, and their House of Representatives will have 40 seats, because I rigged this example to work out. So the most important thing to take away from this is the total population, which is 100,000, and the number of seats that we need, which is 40. I have provided this nice chart here that gives the population of each individual state. For a nice little check to make sure that I'm doing everything legitly, you can add up the total populations, but they do add up to 100,000. So what we want to do is find the standard quota for each state. The standard quota is the number of seats that each state is going to receive, so that will help them divide up their House of Representatives. There are actually 2 different methods for finding the standard quota. I'm going to show both of them to you. They're pretty similar. It boils down to doing stuff in different orders. But you can pick your favorite method out of the 2 and just use that one all the time. So the first method, here's a formula that we use. In order to find the standard quota of State A, we take the population of State A divided by the total population and then multiply that by the total seats. So as long as you can remember this formula, it's pretty easy to do. So going back to my example here, let's look at State A. I put it in a red box so that we can concentrate on it. So here's my formula. You know that State A has a population of 35,000. So I'm just going to replace the population of A in the formula with 35,000. Total population is 100,000. And there are 40 seats. So I've just put the numbers in the appropriate spots in the formulas. And then just do math. Divide first, then multiply. That'll save you trouble. And this comes out to 14. So that means that the standard quota for State A is 14. We can go through this process for all of the other states in order to find their standard quota. One thing I want to point out here is that this makes sense. 35,000 divided by 100,000 is 0.35. 0.35 is equivalent to 35%. So what that means is that, well, 35% of 40 is 14. But what this means for us is basically that since state A has 35% of the population, state A should get 35% of the seats. I think this makes sense. Method number 2 involves something called the standard divisor, which is standardly abbreviated with capital D. So standard divisor is simply that we take the total population divided by the total seats. So in this case, there are 100,000 people and 40 seats. So my standard divisor, I just take 100,000 divided by 40, which is 2,500, and that's my standard divisor. Cool, it's easy to calculate, but what do we need it for? Well, once we've found the standard divisor, we can find the standard quota by just taking the population of each state divided by the standard divisor. So state A's population is 35,000. The standard divisor was 2,500. So we just take 35,000 divided by 2,500 and get 14, which is the same answer we got last time. So that's good. If you are analytically minded, you can actually determine that the two different methods are more or less doing the same thing, just in a different order. Or if you don't care, don't worry about it. So I am going to go through and determine the standard quota for each state. We already figured out state A is 14. To determine the other ones, all I need to do is divide each state's population by the standard divisor, which is 2,500. So for B, I take 25,000 divided by 2,500, and I get 10. For state C, I take 20,000 divided by 2,500, and I get 8. And same thing for state D, and same thing for state E. So I have figured out the standard quota for each state, so I have determined how many seats each state will get. Not too bad, right? Well, it can't be this easy. Actually, it's not. Well, I should say, problem has other problems. Finding the standard quota is fairly easy, but determining the apportionment is a little trickier sometimes.